welcome to Knowledge Lane. So the topic I want to cover today is Macaulay Duration. What Macaulay Duration is, we're going to go through an example so we have some good understanding. So let's get started. So Macaulay Duration, what it does is it measures weighted average time it takes for a bondholder to receive bonds cash flows, which is going to be their coupons plus principal and also their reinvestment income. Okay. So bonds Macaulay duration is positively related to the time to maturity, meaning higher the time to maturity, the greater will be the Macaulay duration, and inversely related to bonds coupon rate and interest rates. So if the coupon rates are higher, you're going to have a lower Macaulay duration, and also if we have higher interest rate, like yield to maturity, right? So that's the market interest rate. So when you have higher interest rate, you're going to have a reinvestment income, which is going to be greater. That reduces the Macaulay duration. So it's kind of inversely related to Macaulay duration. It's coupon rate and the interest rate. And also, if we have a 3-year bond, for example, and we have a Macaulay duration of 1.95, it means an investor will recover bonds cost, the initial payment that you made in 1.95 years. All right, let's jump into an example. So here we have a future value or face value of a bond, which is $1,000. The bond is paying 8% in coupon. We have yield to maturity of 6%. Now, yield to maturity is the market interest rate. One thing to notice here is we have a coupon rate which is higher than yield to maturity, which tells us, this bond is in more demand, right? So if market is only paying 6%, if our bond paying 8% coupon, which tells us, the bond's going to be trading at a premium. And we have a number of years we're going to be, putting this money set aside. It's going to be for 3 years. And if we look into the present value, it's going to be 1,053, higher than the face value. Again, it's trading at a premium. So what are some of the steps to calculate the Macaulay duration? Well, the first step is to identify the cash flows. It's going to be $80, right? The second step will be calculate the present value of each cash flows. So you discount $80 by yield to maturity. You then sum up the present value of all the cash flows. You determine the weights of each cash flows, right? So we'll look into an example where you're going to receive $80 in year 1, and then you find the present value, divide by 1,053. And then you multiply the time period by the weights. So time periods will be year 1, year 2, and year 3 by the respective weights there. And then in the end, sum it up, the step number 5. So here we have year 1, right? So it's going to be 3-year bond. So year 1, we're going to receive $80 in cash. The present value will be 75.47. So you divide 80 by 1.06 to the power 1, and that's the present value. So $80 is the value you're going to receive in the end of year 1. What's the value as of today? It's going to be $75.47, right? Similarly, we have year 2. Going to receive $80 at the end of year 2. The present value is 71.20. And then we have year 3, where you're going to receive the final coupon payment and also your face value of $1,000. And the present value of the 1,080 is nothing but 906.78. So that's the total present value. And then if you're wondering, how we come up with 906.78, so it's nothing but 1,080 divided by 1.06, which is yield to maturity power 3 years. We are just discounting by 3 years. It's going to give you the present value of 906.78. All right. So what about the steps? So here are steps 1, 2, 3, 4, 5, and 6. So let's look into them individually. So step number 1, identify the cash flows. So we have a $1,000 bond paying 8% coupon. So that's where $80 coming up here. And then in the year 3, we're going to receive 1,080. Step number 2, which is calculate the present value of these each cash flows. So $80 present value in year 1, and $80 in year 2, and then 1,080. Said earlier, 906.78. Step number 3, sum up all the present value of all the cash flows. So we just add up all those present value. It should be equals to the price that we initially paid for this bond. So that's the value as of today for all those future payments you're going to receive. Okay. Step number 4, determine the weights of each cash flow. So how do you determine the weights? So 75.47, if you divide by the total value of your investment today. So let's say you invest so you get $75.47 and you put 1,053. So you divide by 1,053, you're gonna get 0.0717, or nothing but 7.17% of your total cash flows you're gonna receive in year 1. 6.76% of your cash flows you're going to receive in year 2, and 86.11% you're going to receive in year 3 because you're going to get your principal. So you calculate the weight by dividing present value by 1053. That's step number 4. Step number 5, multiply the time period by the respective weights. So 1 times 0.0717 and similarly 3 times 0.8611 will give you 2.58. And if you just sum it up, which is step number 6, you're going to get 2.8, which is going to be the Macaulay duration, 2.8 years. So the Macaulay duration, here's the formula. What we are doing is we are taking the present value, which is 75.47, divided by the total present value, which is 1053, multiply that by t equals to 1, and then t equals to 2 for year 2, t equals to 3 for year 3. You do it for all the 3 years and sum it up. That should give us 2.8 years. So what's the interpretation for the Macaulay duration? What does it mean? So basically it takes investor 2.8 years to recover the cost of bond through its cash flows. Okay. So while we are looking into Macaulay duration, we can also just have a quick understanding of what does the modified duration means. It's just an extra step. So let's copy our example. We have same example here. We calculated the Macaulay duration to be 2.8 years. So we can find the modified duration. And before we do, what does it mean? So modified duration measures a bond's price sensitivity to changes in interest rates, right? So it estimates the percentage change in bond's price by 1% change in yield to maturity. So if the market interest goes by, or the yield to maturity in the market goes up by 1%, how it's going to affect the price of our bond? Or if it's go down by 1%, how it's going to affect the price of our bond? So here's the quick definition, is the quick calculation for the modified duration. So all you do is just take the Macaulay duration and divide by 1 plus yield to maturity. And remember, if you have annual payments, n should be equals to 1, but if you are doing semi-annual, you want to just divide it by 2. So you have 2.8%, and we have an annual paying bond, annual coupon bond, so it's going to be 1.06. So you're going to get 2.64 as your modified duration. And how would you interpret that? So all it says, if the interest rates in the market rise by 1%, the price of our bond is expected to fall by 2.64%. Similarly, if the interest rates were to fall by 1%, the price of our bond increases by 2.64%. All right, and then let's quickly glance over some examples where we have, where Macaulay duration is affected by, their coupons and time to maturity. So here we have a case 1 where we have high coupon bond versus a low coupon bond. So bond A have high coupon paying 10%. We have bond B paying only 2%. Everything else is the same. So higher coupon payments in bond A reduces its duration because more cash is received earlier. So lower coupon payments in bond B places more weights kind of on the final principal you're going to receive, increasing its duration compared to the bond A. Okay, so higher the coupon, lower the duration, or lower the coupon, higher the duration. Case number 2, where we have short-term versus long-term bonds. So we have bond C and a bond D. So Its maturity for the bond C is 3 years, while time to maturity for bond D is 10 years. So higher the maturity, higher the duration, right? So bond D has higher duration than bond C. So longer maturity bonds have higher duration because larger portion of their value comes from distant future payments. Okay, whereas short-term bonds have lower duration because the principal is recovered sooner. And then last but not the least, we have zero coupon bond versus a coupon bond. So zero coupon bond doesn't pay any interim cash. All you're gonna receive is $1,000 face value when we hit the time to maturity, or the final payment you're gonna receive in 10 years, right? So since they're not paying any coupons, zero coupon bonds always have a duration equal to their maturity because all the cash flows are received in the end, which is only one, which is $1,000 in cash flow. Whereas bond F has lower duration since it's provide periodic payments, reducing the time it takes to recover the investments. So that's about it. Like, share, and subscribe if you enjoyed the content and find it valuable. And I'll see you next time. Thanks for watching.